Today's lesson is about hydraulics. Before you start the lesson, you should be able to, by now, draw a particle diagram for a solid, liquid or gas using the three boxes here. By the end of the lesson, you should be able to explain, using again particles, how, just by using your foot, you can stop a car. See if you can do that now. By the end of the lesson, everyone in the room should be able to state the equation for pressure and use it to calculate the pressure of a hydraulic system. By the end of the lesson, most of you should be able to rearrange the pressure equation and be able to relate hydraulics to a force multiplier system. By the end of the lesson, some of you will be able to explain using the ideas above, as well as ratios, why hydraulic systems are useful in certain applications. So the big question is today, why is a hydraulic system useful? On the next slide, there are some questions for you to try. See if you can answer them. Pause the video to answer all 4 questions. So the equation that we have to learn today is pressure equals force over area. So pressure is the force per unit area that this force is exerted on. P in the equation stands for pressure. We can use the unit pascals, but that really means newtons per meter squared. Force is always measured in newtons, and area can be meters squared, or if it's more appropriate, you can use centimeters squared or millimeters squared, depending on what the object is. Now we can use the equation in a triangle if you prefer, because the triangle might be able to help us calculate it a lot quicker and better. So we write the F at the top. Under that line we have P times A. So if I wanted to rearrange the equation, it's a lot easier to do so. If I want to calculate force, then I simply cover the F, and I know that's P times A. If I want to work out A, the area, then it will be F over P. And finally, if I want to work out pressure, well, we all know that's F over A. See if you can do these questions. And remember, you can pause the video at any time. Okay, let's try to work these out. So what is the pressure caused by the first or master piston? The master piston is this one on the left. So the pressure, we will need to use the formula. So we have pressure equals force divided by area. Let's try that again. Which equals 500 newtons divided by an area of 20. Which should give you a pressure of 25 newtons per centimetre squared. Now we know that the pressure in the liquid is equal everywhere. So, through this grey part here, we know that all of this liquid will have a 25 newtons per centimetre squared pressure. So when we look at the slave piston on this side, we need to do some rearranging. So number 2, what is the pressure acting on the second slave piston? We know that's 25 already. And number 3, we know the area and the pressure. So what is the force exerted by the second piston? So we want to work out F for force equals pressure times the area equals 25 pressure from liquid, and multiplied by an area of 70 centimeters squared. And this should give you 1,750 newtons. Our next question is that hydraulic systems are known as force multipliers. So why are they known as force multipliers? Well, we started off with 500 newtons, and now we have 1,750 newtons. So a force multiplier is something which converts a small force into a much larger force. What's interesting is that the ratio of forces and the ratio of the areas are the same. If you think about it, the force to the force at the beginning to the force at the end is 1 to 3.5 times bigger. 500 is 3.5 times smaller than 1,750. And if you look at the same 20 and 70, you can also fit that into the same ratio as 1 to 3.5 times bigger. So to recap, a force multiplier is when you can use a small force in order to create a much bigger force, and one of the uses is to use a small force to move much larger objects. So the take-home message today is that the pressure in a liquid is the same everywhere. The pressure acting on both pistons, therefore, will have the same pressure on them because the pressure pushing on both pistons is equal, because it's a liquid that's causing this pressure. On the next slide, see if you can use this and particles to explain how you can stop a car just using the force from your foot.